Let's take this problem which has been asked in JEE Advanced 2020 paper 1, and the question is related to the topic probability. The problem is, let C1 and C2 be two biased coins such that the probability of getting head in a single toss are 2 by 3 and 1 by 3 respectively. Suppose alpha is the number of heads that appear when C1 is tossed twice independently, and suppose beta is the number of heads that appear when C2 is tossed twice independently, then the probability that the roots of the quadratic polynomial x square minus alpha x plus beta are real and equal. So what is there in the question is, we have been given two biased coins C1 and C2. The probability of getting a head on the first coin is given as 2 by 3, and the probability of getting a head for the second coin is 1 by 3. So we have tossed both the coins twice, and we have noted the number of heads which are appearing in the two tosses. So the number of heads can be equal to either 0 or 1 or 2. So suppose alpha is the number of head when the first coin is tossed twice, and beta is the number of heads when the second coin is tossed twice. So the number of heads in both the cases can be either 0, that means we do not get any head, that means both are tails, or we can get one head and one tail, or we can get both the values are both the tosses will give us the outcome as head only. So what are the values of alpha and beta, or we can say what is the range of alpha and beta? Alpha and beta will be taking which all values? So alpha and beta can take either 0, that means we have got 0 heads, or 1 or 2. So these are the possibilities for alpha and beta. Now what he is asking us to find out the probability that the roots of this quadratic equation, that is x square minus alpha x plus beta, are real and equal. So if I take this quadratic equation, x square minus alpha into x plus beta, now the roots of this quadratic polynomials are real and equal, means if I take this quadratic equation x square minus alpha x plus beta equal to 0, it should have the discriminant equal to 0. Discriminant equal to 0 means alpha square minus 4 beta should be equal to 0. Now I will take those cases where alpha square minus 4 beta can be equal to 0, keeping the restriction that alpha and beta both can take the values only 0, 1 and 2. So let us take alpha is equal to 0. What will happen if alpha is equal to 0? We will get beta equal to 0. So our first case will be alpha is equal to 0 and beta is also equal to 0. Alpha and beta both are equal to 0. The second case, if I take say alpha is equal to 2, so it will be 2 square is 4, so beta should also be 2 in that case. No, beta should be equal to 1. When alpha is equal to 2, we have got 4 minus 4 will be equal to 1. So alpha is equal to 2, beta equal to 1 is the second case. Can alpha be equal to 1? If I take alpha is equal to 1, we will not get any of these values from beta, because when alpha is equal to 1, we will have 1 minus 4 beta is equal to 0, means beta equal to 1 by 4, which is not possible. So we have got only two cases with us. Either of the two cases will give us the required favorable case. So here what will happen is, if I say alpha is equal to 0 and beta equal to 0, so here what I will do is, I will use the formula for the binomial distribution, wherein we will use the formula NCR P to the power R Q to the power N minus R. This is the probability of getting R successes out of the N trial, where the probability of success is P for single trial. So then the probability of getting R successes out of the N trial is given by this formula, which we have already studied. Now using this formula, we can say the number of trials is equal to 2 in both the cases, for the first coin as well as for the second coin. So the value of n is equal to 2 here. Value of n is equal to 2 here. For the first coin, the value of p is equal to 1 by 3. So the value of q becomes equal to 1 minus 1 by 3, which is equal to 2 by 3 for the second coin, for the first coin. And for the second coin, the value of p is equal to 1 by 3. So value of q will be 1 minus 1 by 3, which is equal to 2 by 3. So using that concept, if I say what is the probability that the value of alpha is equal to 0, and also the probability that the value of beta is equal to 0. These are the two independent events, so I can multiply both the probabilities using the multiplication theorem. So the value probability that alpha is equal to 0, here n is equal to 2, so I am using this formula. So in this case n is equal to 2 and the value of r is equal to 0, so it is 2c0. The value of p for the first coin, it is 2 by 3, so it is 2 by 3 raised to the power r is equal to 0 in this case. So here q, which is 1 by 3 raised to the power 2 minus 0, which is equal to 2. This is when this is the probability that alpha is equal to 0. Now I will find out probability that beta is also equal to 0. So here also n is equal to 2, so I will write 2c0, but in this case the value of p should be 1 by 3. So I will write 1 by 3 raised to the power 0 into q will be equal to 2 by 3. So 2 by 3 raised to the power 2. So this product will give us the probability that both alpha and beta are equal to 0. So this will be given by 1 multiplied by 1 multiplied by 1 by 9, and here it is 1 multiplied by 1 multiplied by 4 by 9. So this gives me 4 by 81. 4 by 81 is the probability that alpha is equal to 0 and beta equal to 0 from the case 1. So from the case 1 I get p is equal to 4 by 81. P is equal to 4 by 81. Now I am taking the second case when alpha is equal to 2 and also beta is equal to 1. So those two probabilities will be multiplied. So probability that alpha is equal to 2, in this case again n is equal to 2, but here r becomes equal to 2 to NCR, and for first coin p is equal to 2 by 3. So this is 2 by 3 raised to the power, here r is equal to 2 and q is 1 by 3 raised to the power 0. Now multiplied by probability that beta is equal to 1. Now what is the required probability here? P is 1 by 3 and n is equal to 2 and r is equal to 1. So 2c1 multiplied by 1 by 3 raised to the power r, which is equal to 1 here, multiplied by 1 minus 1 by 3, which is 2 by 3 raised to the power n minus r, which is 2 minus 1, that is equal to 1. So what answer we get here is 2c2 is 1 multiplied by 2 by 3 square is 4 by 9 multiplied by 1 by 3 raised to the power 0 is 1. 2c1 is equal to 2 and 1 by 3 into 2 by 3. So what I get here is this is 4 multiplied by 2, which is 8 divided by 9 into 9 is 81. This should be 4 into 2 is 16. No, this is 8 into 2 is 16 by 81. This will give us 16 by 81. 16 by 81 is for the second case. So second case will give us the probability is equal to 16 by 81, and both the cases are favorable to us. Either of this is possible, that means I can add the probabilities. So adding these two probabilities, which is 4 by 81 plus this is 16 by 81, this gives us the result 20 by 81. So the required probability in this case is 20 by 81. So B option is the right answer to this question. So this way we can solve this problem.